everyone for your gracious presence. Your participation is truly valuable, and it's your enthusiasm that fuels the success of this event. I would like to invite our honorable dignitaries to kindly come on stage. Dr. K. Ramesha, Shri R. Venkatadri, Professor A.K. Shukla, Shri R. Madan, Dr. K.J. Sriram, and Dr. N. Anandavalli. Before moving forward to the lineup programs for the event, I request everyone to kindly keep their mobile on silent. We request everyone to rise for invocation.
एक सप्ताह एक प्रयोगशाला माननीय प्रधानमंत्री जी और भारत सरकार के विज्ञान और प्रौद्योगिकी मंत्री के मार्गदर्शन में वैज्ञानिक और औद्योगिक अनुसंधान परिषद की एक पहल है. This campaign aims to showcase technological breakthrough, innovations and achievements by the laboratories for the benefit of industries, public, students and CSIR. The Innovation Engine of India launched this nationwide program in January 2023, and under this campaign, the CSIR laboratory will feature the unique innovations and technological breakthrough to the general public, academic and industrial representatives for a week. जैसा कि हम सभी वैज्ञानिक अन्वेषक और सहयोग के परिवर्तनकारी यात्रा पर आगे बढ़ रहे हैं, हम हरित ऊर्जा के क्षेत्र में अपनी उपलब्धियों का जश्न मनाने के लिए उत्साह और प्रत्याशा से भरे दिल के साथ आज यहाँ एकत्र हुए हैं.
It's a huge opportunity for all of us here to gain insight into the industry requirement and working rigorously on meeting the energy technologies and demands. And also I am confident that through collaboration and engagement, we will make significant strides towards achieving them. Throughout this event, we have an exciting lining up of speakers, deliberations, presentations and discussions. Each session has been thoughtfully curated to inspire, educate and empower all of us. We encourage you to actively participate and share your thoughts and insights to make the most out of this enriching experience. Now, moving forward, we will invoke the blessings of the Almighty with the lighting of the lamp. So, I request our honorable dignitaries to kindly proceed to the lamp lighting ceremony.
Thank you, our honorable dignitaries, for doing the honors. We now request Dr. Alok Pal, Senior Principal Scientist, Scientist in Charge, CSIR-CECRI, Chennai, to graciously extend a ceremonial welcome to our esteemed guests and attendees to deliver the welcome address.
Good morning, everybody. Dear Chief Guest, Shri Venkatadri, our honored guest and my mentor, Professor Shukla, our honored guest, Shri R. Madan, our beloved director, K. Ramesha, our coordinating director of this campus, Taramani campus, Dr. N. Anandwali, our former director and CLRI director, Dr. K. J. Sriram, invited guests from the industry and academia, my colleagues from this campus, my colleagues from our main lab in Karaikudi, and my friends. Welcome to the Energy Technology Meet. We are indeed happy to begin the industry meet of the CSIR Central Electrochemical Research Institute, Chennai unit. I now request our director to welcome the chief guest, Shri Venkatadri, with a bouquet and a shawl. I now request the director to welcome the guest of honor, Professor Shukla, with a bouquet and a shawl. I now request the director to welcome our guest of honor, Shri Madan, with a bouquet and a shawl. I now request the Director to welcome our Coordinating Director, Dr. N. Anandwali, with a bouquet and a shawl. I now request the Director to welcome Dr. K.J. Sriram, Director CLRI, with a bouquet and a shawl. A very warm welcome to much awaited 1 week 1 lab program here at CSIR-CECRI. We are delighted to have all of you join us for this incredible week of scientific exploration and collaboration. CSIR-CECRI has long been at the forefront of groundbreaking research and innovation in the field of electrochemistry. With many scientific research activities, we also are at the forefront of implementing our electrochemical research and using them in industrial applications. CSIR's 1 week 1 lab program is a theme-based campaign ideated by Dr. Jitendra Singh, Honorable Minister of Science and Technology and Vice President of CSIR. It is expected to ignite minds of young innovators, students, startups, academia, and industry, and look for opportunities through deep tech ventures. CSIR's 1 week 1 lab program started on July 22nd and continues till July 29. And today's industry meet is a part of this 1 week 1 lab program of CSIRCRI. Beyond the confines of the laboratory, this program promotes an atmosphere of camaraderie and intellectual exchange. The interactions you have with fellow participants and researchers and from diverse backgrounds will broaden the horizons and foster a spirit of collaboration. As we embark on this scientific odyssey together, your unique perspectives and fresh ideas are indeed invaluable to us. To the younger participants, I encourage you to make the most of this program. Ask questions, seek knowledge, and dare to dream big. This program is a stepping stone towards your journey as an aspiring scientist. And we believe that each one of you has the potential to make a significant impact in the world. Once again, welcome to the 1 week 1 lab program of CSIRCRI. Let us embrace this opportunity with enthusiasm and open minds. Together, we will push the boundaries of electrochemistry and ignite the flame of innovation that will illuminate the path to a brighter future. Thank you, and let the scientific exploration begin.
Thank you, sir, for your welcome address. I would like to call our beloved director, Dr. K. Ramesha, to deliver the presidential address.
Dignitaries on the dais, Dr. R. Venkatadri, Chief Innovation Officer from Tata Chemicals, Professor A.K. Shukla, Professor, Indian Institute of Science and former Director of CSIR-CECRI, Sri Madan, Director, IGSTC, New Delhi, Indo-German Science and Technology Center, Dr. K.J. Sriram, Director, CSR-CLRI, and Dr. K. Anandwali, Director, CSR-SCRC and CMC, and dignitaries from industries and other research organizations, academicians, press and media, and my other CSR-CECRI and whole CSR family, staff, and students. So, warm welcome to all of you for this energy technology meet. So many familiar faces for me from here, from CSR, the SCRC and CMC. when I was here in this CMC as a scientist here in the unit, it was the most comfortable position for me because my house is the CLRI quarters, my office is a CRC. So if there is a problem in office, go to a CRC director. Any problem in the quarters, go to Sriram. So very comfort zone for me that time, and one day, fine day, they decided to put me out from here. So on Saturday, and I took charge as a CSIRCECRI director 2 months ago. So 1 week, 1 lab program of CSR, as already we said, it was initiated by Honorable Science and Technology Minister, Dr. Jitendra Singh. The idea behind this is that CSIR labs will showcase their technologies and whatever innovations they have to industries and researchers and people of India, so that we will strengthen this connectivity between CSR labs and industry, and CSR lab and the academics or students. So student connect, industry connect, and society connect. That was the motto behind this 1 week, 1 lab program. And every CSR lab, one by one, doing this. Already CLRI and SCRC have completed it. For CSIRCRI, this is the 4th day. We started on 24th inauguration, and then foundation day on 25th. And then we had a student connection yesterday, and today also there is a parallel session going on CSIRCRI on IP workshop kind of thing. And here today we are on Industry Connect on energy technologies. So you all know about CSIRCRI. It's the largest institute working on electrochemistry in South Asia. We work on every aspect of electrochemistry, be it corrosion mitigation, electroplating, battery, fuel cells, capacitors, all these things, electromobility, and hydrogen, so and sensors, all these things, kind of things. And I also, Professor Shukla here, who started almost like during his directorship 10-12 years ago. This is what what we call as genius people, and he initiated few programs. For example, hydrogen by water electrolysis. I think 2006 or 7, he got a small seed money from MNRE, and that seeds today become a couple of days ago. We inaugurated Green Hydrogen Lab. So he was much ahead of the time that 12 years ago he thought the importance of hydrogen. And similarly, today we are here in the Chennai unit. It's another, again, far-sightedness of him, that he initiated the fuel cell program 2006, and the battery, lithium-ion battery facility here started in around 2009-10. So now you can see that these three facilities have grown up so much. We have reached some kind of a higher TR level. We are ready to work with the industries and all these things. So thank you so much, sir, for that far-sightedness. 10-12 years ago you started this. And here is Dr. Venkatadri from Tata Chemicals Limited. And we had so many discussions with this TCL group. They worked with us during this ISNGES program. And also thanks to that CSR funding to CSIRCRI for having one testing center. Sir, though it's delayed, it's going to start soon here. Sorry for the delay, this as usual. Madan sir, again, IGSTC supported us so much with the projects, working on new materials and new systems of battery called solid state batteries and all the things. I hope this journey will continue, sir, for us, so CSIRCRI can deliver a lot of things. So this is everything about more or less for CSIRCRI. And I just also want to tell you something that there is always, even now there is a big debate on whether India is ready for all these technologies, whether we have supply chain, whether all these energies are really green, and so many debates. and we will do import substitution together. And CSIRCRI is here for you all industries to take to give you support and also to take your support to deliver to this country. Thank you.
Thank you, sir, for your presidential address and addressing on 1 week, 1 lab program which benefits industry and academic collaborations. With great pleasure, I now extend my invitation to Sri R. Venkatadri, Chief Commercial Officer at Tata Chemicals, to enlighten us with his much anticipated insights, thoughts and perspectives. Sri R. Venkatadri did his BE in Mechanical in 1988 from Veermata Jijabai Technological Institute, Mumbai. Then he joined IIM Lucknow and completed his PGDM in Finance and Cooperations in 1991. He worked in various organizations, starting with Hindustan Level Limited. In 2005, he worked briefly as a senior manager at Tata Chemicals Limited, then served in Rallis India Limited as Chief Operating Officer in 2011. Since April 2019, he is with Tata Chemicals in various roles. From April 2022, he is the Chief Commercial Officer. He has also spent short spells in Harvard Business School in 2017 and in Cornell University in 2017.
On is not this. Huh? From here, left and right. This one. Yeah.
Hello. Hi. Good morning. It's my great honor and pleasure to be as a chief guest for this program today, the Energy Technology Meet of CSIR-CECRI. And it's also an honor that I've got a very distinguished panel of people sitting next to me. Professor Shukla, the originator of many things in CSIRCRI. Madam Anandavalli, who is the coordinating director of this place, Professor Ramesha, Dr. Sriram and Dr. Madan. I'm calling you as doctor. And I'm also happy to see that this program has been organized where both academia as well as industry are together, and I think that's where the future is going to lie. And that's what I will also touch upon in my presentation. I've been, as we've got a whole day of programs where we are going to be diving deep into each of the technologies with very specific references to hydrogen, fuel cell and batteries. So in my opening session, the point would be to set the context of what is the lay of the land, what are the opportunities for both research institutions and for industry, and what is it that we need to do going forward. I'm going to stand here because the screen is here, so if I have to see the screen, I have to stand here. Yeah. So I'll quickly go through, in a quick manner. I'll probably quickly talk about the global context, talk about India, talk about what are the actions that we need to do as a country, and how can R&D institution impact the energy sector, and then a conclusion and a summary. Now at the outset, very clearly we know that, if you look at the global context, with population increasing, with income levels increasing across the world, clearly the need for energy is a continuous, it's a race. Every year we are going to be consuming more and more power, so it's a never-ending rise. Today, if you look at it, almost 81% of all the energy is from fossil fuels, and the critical need that we need to look at is there, that how do we actually handle the energy requirements going in future. Now, from a contextual perspective, of course, while all countries were looking at moving away or reducing the impact of fossil fuel due to sustainability reasons, now the last few years has actually brought in another dimension. What happened during COVID and what happened post-COVID in Ukraine, the Ukraine-Russia war. Clearly what has happened is the world, beside looking at sustainable sources of energy, is also realized the geopolitical changes that have taken place, and it has actually hastened countries to look at self-reliance. And we have seen that what has how Europe has got badly impacted because of the Russian-Ukraine war. So countries are saying, how can I be more self-reliant? Also what has happened is that given the kind of carbon emissions that have taken place over the last so many years, rather indiscriminately, I think we have not been very kind to nature, only focusing, if we have to work on carbon dioxide reduction, besides working on moving to renewable sources where we are reducing creation of new carbon dioxide, how do we actually also reduce the carbon dioxide? So that's going to be another critical thing that we'll have to focus on. Clearly, I think when we look at the trends that are there, over the next 20-30 years, we can see that while energy consumption is going to go up, but there are also certain macroeconomic shifts that are taking place in terms of how hydrogen demand is actually going up substantially across the world, how people are also looking at solar energy, wind energy, and obviously the whole area of fuel cells as well as green hydrogen. So that's a big shift that's happening. And if you look at it, that the estimate is that renewables would account for 80-90% of the power generation by 2050. But even if we do that, the climatic issues of increasing temperature will still not be avoided, and we expect that almost 1.7 degrees would increase by 2100. If we need to leave our grandchildren a better world, I think it's important to look at how do we handle the sustainability part of it. Stepping on to India, all said and done, we all are aware that today India is galloping as a country, and we are probably one of the fastest growing economies in the world in spite of all the crisis, and soon we would be the third largest economy in the world, give or take a couple of years. But I'm sure by the end of this 10-year journey, 2020 to 2030, India should be there in number 3. Clearly, I think India has been quite reliant on fossil fuels, whether it is coal or whether it is petroleum, in terms of natural gas. And obviously we do have a lot of energy that we consume because of reliance of these two sources. In fact, almost 80% of India's energy gets consumed between coal, oil and certain other biomass. But if we need to sustain the growth, it is important how do we actually build in energy security for the country. And that is what is actually going to look at how can we look at other forms of energy and how do we look at some of the renewable sources of energy. Now, one good thing that has happened at a country level, and thanks to the government which has taken a very big lead, India is probably the only country which has actually been very close to achieving the target that it set for itself in the Paris Agreement. Even the so-called advanced countries are very, very far away. We are almost 95% of the target that we had taken. And we have also talked about how will we move to non-fossil energy capacity by 2030, and that's something that we have, as a country, we have committed. Now, the mitigation steps that we need to look at has to happen at two levels. One is how do we actually manage the growing energy deficit that we have, and second, importantly, how do we focus on alternate sources of energy, whether it is nuclear, solar, wind, etc. And ultimately, I think we need to, as a country, we need to be self-reliant as much as possible in energy, given the current geopolitical situation. Now, if we look at the future trends, clearly I think the electricity consumption is probably going to be the CAGR of almost 5%, which is probably going to be the highest across all countries. That shows, while at one end it's happy that we are growing as a country, but it also puts a lot of pressure on the energy requirement. We've also seen, due to governmental support, solar energy has become a very, very big portion of our future requirements. Many companies have actually started looking at setting up solar parks, and because of obviously, you know, the government has been very supportive by giving taxation benefits, this has actually become a very, very useful form of energy. And there is one potential that we have not yet utilized, and I'm sure at some point of time India will realize it, which is how do we move more and more into rooftop solar energy. Given that India gets almost 8 months in a year good sunshine, how can we actually leverage that? Now, if I look at it in terms of the various government policies that have been there, I'm not going to read through each one of them, but just to say that whether it is generation, whether it is transmission or its distribution, I think very clearly the government has shown its intention by coming out with a number of policy initiatives to really shift the country from where it is to where we are. Clearly we are today far more comfortable than where we were a few years back. And it's also evident in a manner that when this Russian-Ukraine war took place, the decision to continue to buy the Russian oil was a decision taken to protect the self-interest of the country. I think that also demonstrated the ability to take tough decisions. Now, quickly I'll just say that the Prime Minister has set the top priorities for the country, which is known as the Panchamrit, which is expand the non-fuel based energy capacity to 500 gigawatts by 2030, provide 50% of India's energy needs using renewable sources, reduce carbon emission by 1 billion tons, cut the economy's carbon intensity to less than 45%, and achieve net zero emissions by 2070. Actually, India has taken a very strong lead across most of the countries, and amongst the developing country probably we are taken one of the toughest targets, which is very good. And clearly if this we have to achieve, it requires us to really work on a lot of technology. Now, all of it cannot be achieved if technological interventions and by research institutions like CSIRCECRI, it makes very clear that we need to work on it. If I quickly look at the three main areas, I'm not going to dive into each one of them in detail because there are very detailed sessions in the afternoon, but just to highlight the critical opportunities and the challenges. I'll always say challenge is actually good to have, because if you have a challenge, there is work for R&D, because then you can work on it to sort it out. If you look at clearly the EV batteries, there's a lot of work that has happened to improve the efficiency, but there is a lot more work that we need to do to improve the energy density as well as the cost. Now, clearly if we look at from a cost perspective, we are dependent on imports for many of our critical input material. And while government has given a PLI scheme to encourage manufacturing, but clearly, somebody is paying the price for it, whether it is industry or the government, but finally it's the country which is funding it. So the only way we can actually reduce the impact on it is actually the first point, which is the technologies that we need to work on, whether it's solid state, whether it is lithium sulfide, whether it is sodium, flow batteries, and a lot more. These are very critical. Obviously, one of the challenges that we need to address on, which we all have recognized it, but I think a lot more we need to do, is how do we handle the environment impact of making batteries and then recycling batteries. So this is actually going to be a big opportunity for R&D scientists to look at. Fuel cells, it's going to have a huge potential for the larger vehicles like trucks and cargos and longer distances. But clearly I think cost is still an issue which is still there, and we need to actually address that. And again, technological solutions are required. I would say the biggest advantage or the biggest opportunity for India is also in the area of hydrogen. Now clearly we are in grey hydrogen, and it's important for us to keep working on green hydrogen, and that's where the future is going to be. if I look at some of the key actions that comes from all of it is how do we actually scale green energy, how do we actually boost the green hydrogen, accelerating carbon capture. Many countries, like for example UK, has put in a very good system for, how do we actually monetize carbon capture. I think India also should come with such a concept, and that is something which will hasten the movement going forward. And also, how do we increase the domestic capacity for production for all forms of energy. Now, one critical thing that we need to do is there that if all of this has to happen, we have seen that research institutions like CSIRCECRI and others are working on it. We've also seen a lot of industries are working on it, whether it's a Tata Group, whether it's Reliance, L&T, Mahindra. Almost all companies are working on these modern technologies. And similarly, the institutes like CSIRCECRI are working on it. While there is a lot of collaboration, but I would urge that I think if we have to go to the next level, I think it's important for R&D institutions and companies to work together, because they are complementary to each other, because they have strengths but they need each other for leveraging what they are not good at. For example, the scaling up capacity has to be with the industry, and the capability to do R&D has to be with research institution. So it's, I would say, a marriage made in heaven. So clearly I think where are the collaboration opportunities which I see is one, technology development transfer. I think that is something that we need to do better. One of the things that I would actually urge the industry is there that Indian industry also has to realize that Indian industry has to pay for technology. The propensity to pay to R&D institutions has to be recognized. Nothing is free in life. One thing that we all, we see that in India, knowledge is something we all are not very keen on paying. But I think it's important to pay, and that is something that we could learn from many other countries. Pilot projects and demonstrations. Again, like for example, at Tata Chemicals and CSIRCECRI are working together to create that what Dr. Ramesha mentioned about, to put up a demo facility. I think lot more companies need to come forward to really work on it and do this hand holding with each other. Similarly, funding and investments. Obviously, the benefit of the technology is going to definitely accrue to industry. So industry has to put in its bit to be able to fund it. Testbed facilities are required clearly. Knowledge sharing and capability building. There could be a lot of joint ventures today within our in our country between research institutions and tech industry. There are not too many good models where they can do joint ventures. I mean, this is something which I would request the CSIR team to look at how can it be taken up at a policy level, so that the industry and there can actually have a joint ownership, a joint collaboration, and each player plays a role. And finally, the market deployment and scaling it up. Excuse me, not moving. I think battery is gone. It's come. Yeah, thanks. So if I summarize the part, what I talked about is there that clearly India's energy needs are galloping. We need to have more sustainable and self-sufficient sources of energy. There is need to work in solar, wind, fuel cells, green hydrogen, lot of opportunities. R&D institutions have a major role in them. And industry has a major role to partner with R&D institutions. Government to continue with its support. Till now the government has played a good part in supporting with good policies, and it should continue doing that. Here I would actually call out and say that CSIRCECRI is at a pivotal or at a center stage. You are at a vantage position that today, given that energy is a crucial part of it, and CSIRCECRI is a key leader in that technology, I think this institute has that opportunity to play the key role, to play a defining role for the country. And clearly, I think what I would also say is that today there is a lot of sessions that are there, and there is industry, there are R&D institutions going to talk about it. I think the key part of it is that the value of the conference would be achieved if provided there are insights that are drawn from both the sides. Certain actions are arrived at, and when people get back, whether the R&D institute or an industry gets back, it discusses internally and then commits that they will work on it, then the purpose of the conference would really gain the benefit that it deserves, which is, finally everything has to get translated into action for the world to go ahead. And to summarize, I would again like to thank CSIRCECRI for organizing this brilliant workshop. The technology meet, very, very relevant at this point of time. You've got great speakers from industry and from academia to talk about and discuss and debate. It's going to be a lot of value adding for all the participants who are here, and I wish the program all the success. Thank you all very much.
Thank you, sir, for your valuable insights on global energy impact policies and India's potential for fuel cell and electrical vehicles. Now, with great honor, I am delighted to invite our distinguished Professor A.K. Shukla from ISC Bangalore and former Director CSIR-CECRI to share his perceptive thoughts with us. Professor A.K. Shukla did his PhD under the guidance of Bharat Ratna Professor C.N.R. Rao in 1978 and soon after joined as faculty in Solid State and Structural Chemistry Unit of Indian Institute of Science. He served as a director of CSIR-CECRI during 2003 to 2009. He worked extensively on fuel cell, storage batteries and supercapacitors. Professor Shukla is fellow of all leading academics such as fellow of the Indian Academy of Sciences Bangalore, fellow of National Academy of Science, fellow of Indian National Academy of Engineering, fellow of Indian National Science Academy. He is also fellow of two leading societies in the world in the area of electrochemistry, the Electrochemical Society USA and International Society of Electrochemistry. He served on the editorial board of many international journals, including the Journal of Electrochemical Society. With brief introduction, now I would like to call Professor A.K. Shukla.
आगे बढ़ाने के लिए ये पॉइंटर है, ये आगे बढ़ाने के लिए। बैटरी प्रॉब्लम of my talk. Can we get down with the lights a little bit down? Then is it visible to you all? Please, yeah, this is better. So, in the beginning I must. Okay. Okay. So, honorable guests, delegates, ladies and gentlemen, a very good morning to you all. I think still we have time to say you good afternoon. So I think this is a very good morning. And I am so delighted to see many of my friends and colleagues over here. So that gives me some pleasure and some satisfaction to my heart. Okay, the topic of the much has been said already by So much has been said by Dr. Venkatadri about the importance of the power systems which is driven by electrochemistry, the electrochemical power sources. My talk today is on sustainability of fueling future cars. So, you all know what sustainability is, and I have put the definition over here, but the idea is that you should have something which sustains your future generations. Well, with that, if you turn up the noted science journal, or you'll find that it all started. The road transportation has been the basic need of the humanity, and all this started way back in 1899 when the good old lead acid battery was used to propel the electric vehicle, and it ran with an autonomy of 80 kilometers at a speed of 109 kilometers per hour. It was all electric batteries, that is the batteries at that time. But then great Edison came, and then you see he has some thinking about against lead acid battery. He started the good old nickel iron battery. One of my friend who has given up nickel iron battery is sitting here, Dr. Hari Prakash. He worked on nickel iron battery, and then you see he was the one in the literature. If you look at it, he was able to seal the nickel iron battery. Very daunting task. Well, he is doing something else today. I am very grateful to him that he has come here and graced the occasion. Well, so Edison, the great Edison, started nickel iron batteries at that time, and he started propelling the cars on the roads of in the New York. Well, to replace the horse carts, the challenge was how to remove the horse carts. Well, if you look at the history, in 1900 in US, the electric cars were actually dominating. There are 1,500 electric cars vis-a-vis about 1,000 automobile vehicles. But, as the time passed, कहाँ गया भैया? इधर आ जाओ यार, you come here. Some more. As the time passed, cheap fossil fuels became available, and that time the invention of internal combustion engine was made, and the ICEVs cars, and then I think everybody in this audience has a car at least. And the house they may be having, actually there are people who have 4 or 5 cars, they don't know what to do with it. Now, well, what is happening there is that, as Dr. Venkatadri already mentioned, the carbon component, the carbon footprint started growing. And as a result, what happened? It brought planetary emergencies. Planetary emergency in terms of global warming, climate change, air pollution, fossil fuel depletion, and environmental effects that are too well to be known to you to be recounted here. Well, so these environmental changes, politicians also realized that there is a need, and the political issues started pushing the electric cars, and the power systems needed to be developed. Alternatives, of course, were at that time, if you have to go to green, that means you have to bring down the carbon footprint. It was very clear that you have to go electric, and how we began to electric, I will talk about in the forthcoming slides. Well, to what is the electric transportation has been facilitated, we started developing the global need wanted hybrid electric vehicles, and so on, so to build a better environment. Well, now at this stage I have to be slightly mathematical. What you need when you decide to develop an electric power system, you got to think of power and energy estimates. Everybody talks about what is the power density, what the energy density, and so was the situation with electric cars. And you will see the power estimates. Don't worry, very simple mathematics, don't worry about it. So parameters that a typical modern medium size I am taking a consideration. You take the typical modern medium sized car, which has a weight of about 1400 kgs, a frontal area of about 2.2 meter squares, and the tire friction coefficient that you, of course, you realize that there is a friction. Without friction nothing will move. So the tire friction component, which is taken typically from literature, is usually of 0.01, and aerodynamic drag, wind and other factors, you take it at 0.3 in the typical number. And the density of air you all know, I just recall back 1.17 kilograms per meter cube. And so the car traction kinematics tells you that the power traction, the total traction power that will be needed will be sum total of P gradient, that is power on the gradient that you feel, the acceleration, the tire friction, and also the aerodynamic drag. So these are the 4 components which are needed. Of course, the road camber I am neglecting because the road's camber will change from place to place. So in this place you just neglect that component. It is an important component, has to be taken into consideration. Now if you do look at the Newtonian kinematics, very simple. You know the potential energy, you just differentiate it with time. You will find it will be mg by v sine theta. Very simple. X sine theta is the height. So mg x sine theta, you differentiate it. With respect to t, you will get mg v sine theta, dx by dt is v. And then you go to acceleration, with kinetic energy, once again differentiate with time, you will get mass into acceleration into velocity. Now some empirical relations which are available in the literature, you just see P tires is given as tire friction coefficient, mass of the vehicle, acceleration to gravity, and then velocity. And then P arrow in the similar fashion is 0.5 in the density of air multiplied by the aerodynamic grad, the area, frontal area of cross section, velocity, wind velocity, and also the velocity of the vehicle squares, and then v. This is what called, these are empirical relations I have taken from literature. They are very well available, and I am not going to talk about them. If you need to know much about them, please come to me after the lecture. I will be very glad to tell you. Now, he has gone back. Now you take examples. For example, I have taken P tires at various speeds of the car at 50 and 100 kilometers, and you work out. You find that 50 and 100 kilometers, at 50 it is 1.9 kilowatt of power is needed, while at 100 kilometers per hour it is 3.81. That is a linear relationship. The calculation says that the P tires to be are linearly dependent of velocity. Now, if you can go for aero, for example, in a similar way, you can calculate. You had 1.03 kilowatt at 50, and at 100 it is 8.27 kilometers. If you the calculation says that P is very demanding at higher speeds. Now, if you calculate I have taken 10% gradient, which you usually come through in the cities. You find it is also linearly dependent onto the and then of course the acceleration also you see these two components are all linearly dependent to each other, that is on the velocity. Well, if you have not followed that, you don't have to bother. You see this, I have just put the summary of this. So there are 4 points, there are 3 points that you have to remember, that at substantial 10% gradient, climbing at 50 kilometers per hour requires about 20 kilowatt, including tire friction and aerodynamic drag. Acceleration, as you saw, is more demanding, particularly at high speeds. For example, acceleration at 5 kilometers per hour requires 30 kilowatt at 50 kilometers per hour and increases to 66 kilowatt at 100 kilometers per hour. Taking, which is present days cars are giving, taking well to wheel efficiency of 0.85, and that is 85%, and additional power accessories, that is steering and power steering and air conditioning, about a 5 kilowatt. The total power that is required is P traction divided by the energy, the silent drive, that is wheel efficiency, plus the total P accessories. The accessories which are important. Now if you add it up, that accessories power is about 5 kilowatt, and then if you put the 85% efficiency, it all works out to be 30 kilowatt. For your car, minimum power that you require for a medium sized car is about 30 kilowatt. Now, so now you have known this. As an educated person, you have these numbers at your hand. I don't know whether you have ever thought of the sustained power of an electric car, the medium size, is about 30 kilowatt. When you speed up, but the burst power rises to about 30 kilowatt. But cruising powers, when you are giving it higher gears, it is about 10 kilowatt. So keep these numbers in mind. and go ahead for the power system that you will develop. Always know that simple chemical engineering calculation tells you that heating value of gasoline, for example, is 32.49 megajoules per liter, which is keeping the car efficiency. I have taken a 20% efficiency. It will work out to be 6.5 megajoules per liter. Now, which is equivalent to 1.82 kilowatt hour per liter, or in other words, you can say 182 watt hour per kilometer. For a medium-sized car, for a drive range, usually I will say 10 kilometers per liter, that you are consuming per liter of the fuel. For a diesel car, where the efficiency is slightly more, 30%, it will work out to be about 201 watt hour per kilometer. On the average, you see about 200 watt hour per kilometer is needed. Now we are coming to electricity. Electricity, that is, we are going to derive from the storage batteries, so-called supercapacitors, and the fuel cells. Dr. Venkatadri has already touched upon. Those who have not bothered to learn about storage batteries, I always tell to my younger friends that they should know. Anyone in the village asks you what is a battery, so a device that converts the chemical energy stored in the active materials directly into electrical energy by means of an electrochemical oxidation reaction. It has no Carnot limitations. Now, those who have forgotten, once again I will remind them, we have two electrodes. One is doing oxidation, anodic oxidation, cathodic reduction. Now, so I have written certain reactions. The electron generated at the anode, that is a negative plate, goes, the industry doesn't like anode and cathode. When you are going for an interview to an industry, don't talk negative plate and anode and cathode. Say negative and positive, otherwise they will throw you out. Now, that electron goes through the load and meets the, and is consumed at the cathode, and if you put a load, which is could be anything, a motor or a electric bulb, it will fire the system. Now, charge and discharge process therefore are the very seminal thing, and you know, when the electron goes from anode to the cathode or from the negative to the positive, it loses energy, and energy per unit charge, you know, is voltage, and the current is flowing current multiplies voltage power. That is the source of power that you are deriving from power system. Now, another component which is desirable, that the energy delivered by the battery, energy density, should be as high as possible. How you do it, it is your problem. An engineer who is looking for this product from your hand never cares for it. So, you have the energy density should be maximum. That is his demand, and how you meet it. Well, energy density is a definition, as I told you, is engineering quantity. Quantity electricity stored per kg of the battery weight. All of you know it, and the volume is also very critical. So you keep the volumetric energy also in mind. Now, how to calculate the capacity is very simple. You have 26 the great Faraday, which is gave you the Faraday number is 26.8 ampere hour, and then the number of electrons, for example, in lithium it is 1, and molecular weight or the atomic weight of the substance that which is the active material is in question. Now, simple calculation similarly for the well-known lead acid battery, which is the first commercial battery which was used by the industry and the public. For the lead acid battery, it was the exact, you find the specific energy is 176 watt hour per kg, but practically you get close to the best battery will give you about 35 watt hour per kg. Well, that means that there is a lot to be done in the case of lead acid batteries. Theoretically we are so much, but experimentally we are far down. The speed of delivery is the power density, though is the power density, energy density derived by energy, but both high energy and power density are called for by the engineering point of view. Now, the acceleration is power density is more important than energy density. Therefore, if you look at the competing rechargeable batteries, you will find starting from the lead acid today we are standing at the we are vouching for our lithium batteries that can give quite high power density as also the energy density. So the systems have become compact. As you saw in the beginning, huge truck-like vehicles, the electric vehicles are becoming compact. Now, what are the implications of this calculation that we did for well? From the cost perspective, lead-acid batteries are most attractive, but with an energy density of just 35 watt-hour per kg, about 6 kg of the battery weight is required to drive a 1 kilometer vehicle. Lead-acid battery cars can never be matched their performance of internal combustion inverter combustion engine vehicles, and can best be used for neighborhood applications. Lead-acid batteries are most sustainable batteries. Even today, lead-acid batteries are having a very seminal role in our lives. Lithium secondary, the so-called super batteries are becoming cost intensive, and a battery weight of 1 to 1.5 kg is required to travel 1 kilometer. Keep in mind, about 1 kilometer, which looks compelling, very attractive, but lithium batteries are not sustainable. You all know that lithium is limited. We have to cycle the lithium if we have to make them sustainable. Now, as of today, these cannot be recycled cost effectively, a big challenge for the electrochemists. Lithium air batteries are being talked about, very high energy density, about almost matching the internal combustion engines, but you know, there are technical problems. The technical problems I will put in electrochemical language, but don't bother. If you want to learn about the calculations, you see me afterwards. A large amount of energy is required, is generated by the metal air batteries used up in the process of auxiliaries. That means lot of oxygen or the air, that is oxygen from the air, has to be pushed to the system. The battery, so that's why this metal air batteries are not the successful components of pushing the electric vehicles. That's why, you know, though the Americans spent, the Department of Energy spent a lot of energy in the beginning, including GM, they have given up the air-based technologies. Now, lithium consumption, I just want to warn you, market consumption will be tripled from 160,000 metric tons to a staggering 470,000 metric tons by 2025. And even if EV market 1% increase is there, lithium demand will be 70,000 metric tons, which is about half of the demand, market demand today. Keep that factor in mind. So therefore, you have to look at alternative systems. The supercaps, can they give the thrust power demanded by the systems? Well, I don't want to get into the details of capacitor, you all know that. There are various basics and all that I am not including today because of the lack of time. And you know, the more important thing that I tell you, the electrochemical capacitors. That, you know, that electrochemical capacitors are of various types, and you see, the most of the thing is that electrical double layer, which was known way back 1853, Helmholtz he demonstrated that could be a double layer, and that this double layer can give you a huge amount of capacitance. Well, these are the systems that I have just compared. It is very clear that electrochemical systems can reduce the mass, but the response time is limited. Well, I have done another calculation just to show you that supercapacitors are basically a power device. So when you need the thrust power, you can actually use the supercapacitors. Well, the other system that which is dear to my heart, you see, is fuel cells. Electrochemical engines, that is, they convert the chemical energy directly to electricity. I am very glad to see my guru, Sridhar, is here. He actually pushed the fuel cell program right in CSIRCECRI, and whatever CSIRCRI is now banking on is the efforts that made by Dr. Sridhar. The difference between a battery and fuel cell can be related to the definitions of thermodynamic system and thermodynamic control volume. I always insist on these two numbers. The chemical engineers know very well I see some chemical engineers sitting in the front. In a thermodynamic system, no mass flux is permitted to cross the system boundaries, that is a battery, while in a thermodynamic control volume, mass flux is permitted across the boundaries, as in the case of fuel cells. Fuel cells gives you very high energy density. Energy density is actually unlimited. These fuels have the potential to solve the most challenging problem associated with the currently available batteries, namely their limited energy density. Well, I don't want to get into these things. I just want to insist upon you that they beat the Carnot limitations, and which is a limiting factor in case of conventional our IC engines. So there are various types of fuel cells which we have known by now. The solid PM, and then you have aqueous KOH system, phosphoric acid system, molten carbonate, and also high temperature fuel cell systems. But what is prevailing in the case of electric vehicles is basically the polymer electrolyte systems. There is some role for the direct methanol fuel system which will come in the future. Well, going ahead, this is just the working principle. I just wanted to show you that there is a polymer electrolyte film. So a lot of polymer, the making polymer membranes or the effective membranes is very, very critical, and I am glad that CSIRCECRI and other organizations are definitely giving their concentration on this R&D. Now, specific energy of this, for example, PEM is very attractive. You see, hydrogen is a fuel, and it gives you 33 kilowatt hour per kg, which is very, very attractive number. Now, how it works is all very colorful, but putting it together is great engineering talks. I am glad CSIRCECRI is building systems these days, and they have also passed on the technologies to the industry, which is very pivotal. Now, then what you have seen, the PFC implying an external hydrogen feed through a catalytic reformer, as I demonstrated over here, it has been difficult to find such effective carbon monoxide tolerant anode catalysts. So this is another component that is being groomed in CSIRCRI, and then you come to the green hydrogen. So therefore, since you are looking for methanol, carbon dioxide monoxide tolerant anode catalyst, which is a daunting task, what is the best is you move to electrolyzers, where you produce green hydrogen. Green hydrogen can be only produced through electrolyzers, and electrochemistry has a seminal role to play in that direction. We can fuel the cars using polymer electrolyte fuel cells, and then we can power them with the green hydrogen. This will, just a minute, this will provide you a sustainable route. That's why people are talking about green hydrogen. You run your car on PFC, and this provides a sustainable route. Green, carbon footprint down, you are there in the contention. So what I mean to say is many countries are believing that batteries is not the ultimate route. They have to move. They have to find a cost-effective route to generate green hydrogen and build PF systems which are cost-effective. They are comparable with the batteries. Then you are in the contention. But this leads to difficulties in cost-effective hydrogen storage. I once again add that PFC powered by directly fueled fuel cells will be definitely attractive. For example, methanol, which gives you a hydrogen content about 12.5 weight, which meets the commercial need, and therefore the methanol fuel cells are also very important, and CSIRCRI is doing some work in this direction. I am so pleased about it. Now, don't bother about this becomes too academic. You see, you can get, without 33 kilowatt hours per hydrogen, you can still get 3 kilowatt hours per energy using direct methanol fuel cells. So they will have a future implication. As the time passes, you will see there will be methanol economy will definitely come in play. But there are limitations. As I indicated, methanol impermeable membranes have to be done. Good things are being done at CSIRCRI. Methanol tolerant oxygen reduction catalysts have been found. Our friends in the CSIRCRI are also working in direction. If you read that, you will see you have two cars, one driven by PFC, the other driven by direct methanol cells. You will see the difference. The whole thing becomes very compact and simple and hence cost effective with methanol. Now, this is a Ragone diagram that I have indicated. What you have to do, the Holy grail is to touch this part, the ICV engine, which gives you about which is needed 1 kilowatt per kg and 1 kilowatt hour per kg of energy density. This is the holy grail, and much work has to be done in this direction. Okay, so you have a full powertrain of comprising starting from capacitors down to fuel cells. You have to, these are the concepts that I have thrown, but then the concepts have to be converted into context to facilitate sustainable future cars. Well, if you do that, you will achieve green cars that will change the world. The pollution will be mitigated, carbon print will be down, and we will have a cleaner and greener world. But this is a great challenge which all of us, the entire community, has to face. With all that, no, time is up. Any questions?
Yeah, we will take it later.
Okay.
Thank you, sir, for your enlightened words and motivation, and also for your valuable information on sustainability of fueling future cars, and also power and energy estimates of an electric car. Now, I would like to invite Shri R. Madan, Director, IGSTC New Delhi, to graciously share his invaluable insights. Shri Madan did his BE from NIT Calicut and Master Degree from NIT Surat. From 1991 to 2020, he was associated with CSIR National Institute of Oceanography, Goa. He served as a chief scientist and head of the Marine Instrumentation Department at CSIR NIO. He has contributed to the development of several marine robots, including autonomous underwater vehicle, remotely operated surface vehicles, and autonomous vertical profilers. Shri R. Madan has taken over the position to lead the bilateral Indo-German Science and Technology Center as its director on 29 December 2020 and has been actively catalyzing Indo-German Science and Technology partnerships. He is the recipient of the Meritorious Invention Award from the National Research Development Corporation, Ministry of Science and Technology, New Delhi, for Autonomous Vertical Profiler for the year 2010. He is the Fellow of the Institution of Engineers, India. With this brief introduction, I would like to call Shri R. Madan.
Thank you very much. My dear CSIR family, I'm also a proud CSIR family member, distinguished guests from all over India, industry personnel. So my talk is very different from what Professor Shukla and what Mr. Venkatadri talked about. So I'm going to talk about fostering applied research because that's very close to my heart and it's very close to what the Indo-German Science and Technology Center funds. So whenever you talk about applied research, I think this is one chart which comes to your mind always. Where do you position yourself in the TRL level? So, and I think it's a very important question. Although there are just 9 levels, if you have developed technology, you will find many levels between 1 and 2, between 2 and 3. And it's very challenging to say that I'm at 3 and I'm at 4. But of course, these are standards followed all over the world. And then the next thing is, as academicians and scientists, when do you want to involve industry? This is a big question. And when industry wants to involve a scientist or an academic person for a product, for an applied research process or a translational research process. So some of us might think, yes, we have done the technology validation in the lab and we have demonstrated it in relevant environment. So we'll say it's here, we want to do it, let's get the industry here. I don't know whether this is the right proposition, or maybe you think you've done a good experimental proof of concept and then you say let's involve the industry right from maybe TRL level 4, 3 to 4. Is that good enough? But I think today people are looking at hand-holding right from the beginning. And I think this is very important. So I would say the old concepts are gone, and this is where we really are getting into. And this is where the center, IGSTC, funds programs. I think as a developed nation, we are looking at applied research as a big enhancement in our S&T policies. But there is another big question which arises. Who instigates this first level? Is it the industry, or is it the brilliant scientist, the brilliant academician? I think this is a very important question. Sometimes scientists come up with very novel ideas. Maybe, unfortunately, it might not be useful at that point of time. But there are many times they come up with brilliant ideas which can connect with the industries. But many a times, I think the real challenging questions come from industry. So that takes me to my next area. So what are the things we need to really be good at when we talk about applied research or translational research? So if you look at the key aspects, there are 3 areas I think we really focus. And I think this is generally done all over the world. Number 1, you should be ready to do joint R&D and innovative projects with industry. With industry, not as scientific or administrative groups. The second thing is, I think you need to continuously network with industry, and I think that is what One Lab, 1 Week CSIR is doing. It's really networking with industry, and I think that is really very, very important. And the third thing is continuous capacity building. And these 3 key aspects are also part of our funding program at IGSTC, and I'm very happy that it's a part of our program because it goes with global standards of these 3 aspects which support applied and translational research. So then, how do you enhance bilateral partnership? Now, you can have applied research in India, and you can do it with industries, but what we as a bilateral nation do it with Germany. So how do we do it? So just let me take you through this S&T landscape of Germany. So if you look India and at Germany, we have the 2 ministries with similar funding, the science ministries. And then we have major funding tools like we have ISRO in India, MOES in India, we have DLR, similar to that in Germany. And then we have another layer, very similar to Indian labs like CSIR. We have the Fraunhofer labs in Germany. We have Max Planck institutes which are focusing on basic and fundamental research. We have the Leibniz institutes. We have the Helmholtz institutes. And similarly in India, we have the ICMR, ICAR, DBT labs, and other research institutes. And then we have a next level of institutions. Like India, you have the Indian Institute of Science, the IITs, the NITs, and a lot of applied research, applied science institutions. And similarly, you have this at Germany also. And of course, you have state universities, state institutions, and very similar in Germany. So you see, the landscape is very similar in India and Germany. So I think it's a matter of connect. And then you have startups and industries in both countries, which are flourishing. So I think what is important is how do we connect and how do we take applied research to a next level. Germany is doing very well in this. The Fraunhofer labs are supposed to be one of the top labs in the world doing applied research. And I think we need to have some connect with Germany. And what IGSTC at our center does is basically helps you to connect any parallel to any parallel. Otherwise, you'll end up connecting to one institution. So what our programs basically let you do is connect any parallel to any parallel. So this is basically what I want to say during my inaugural talk. But I think I'll be a little selfish, and with my loyalty to the IGSTC, I'll just run you through 3 programs. We have funding many programs, but 3 which highlight capacity building, which highlight networking, and joint projects. So one of the ones for capacity building is we are funding a lot of Indian PhDs and postdocs to go to German industries, get trained for a year, and come back to Indian systems. And I'm very happy that SCRC in CSIR-CECRI has many of these industrial fellows who have gone to Germany. They've come back, and I'm sure it'll raise the levels at SCRC. I'm not sure if anyone is present here at the moment. Yes, there we have one. Thanks for coming. We are also going to have people from CSIRCECRI soon. They've been selected. So it's something which will transform. Yes, thank you. So I think this will transform a lot within this system. And this is where I say capacity building is very important. The other important thing is networking. And we do fund these workshops to a big amount. And the important part of our workshop is 50% of the partnership is from industry. So the workshops are basically for industries to ask the challenging questions to the academicians and the scientists. And if scientists can solve those, it becomes an automatic applied research or translational research problem. And we fund those sort of situations. And finally, we do fund the big projects to the tune of 3.5 crores for each site, so it's close to around 7 to 8 crores. And we are very happy that these projects are announced on thematic areas every year. We have 7 projects funded, and we are very happy that CSIRCECRI already has a project on this. It's on advanced lithium-ion transporting solid electrolytes for solid-state lithium batteries. Thanks to Dr. Prakash and Dr. Ramesha, who really spearheaded this program. And I think it's a good success story, and they've learned a lot from this. And I'm sure they will be contributing more. And we have very good calls coming up in the future. We have one on waste to wealth and sustainable packaging coming up, and we also have one on AI for sustainability coming up in the future. So this is a small talk about applied research and what our center can help, in which way, and what possibilities are there. I hope this fits into the welcome remarks at this wonderful event organized. Thank you, Dr. Ramesha, for inviting me. I'll say thank you. And just to show you the network we have created through IGSTC. Thank you very much. Yeah.
Thank you, sir. Thank you for kind words and motivation on applied research, involvement of industries for research at various levels, bilateral partnerships and projects. Moving forward, with great pleasure, I extend a warm invitation to our esteemed guest, Dr. K.J. Shriram, Director of CSIR-CCRI, Chennai, to deliver his special address.
Thank you very much. First of all, before I get going into this, it gives me tremendous pleasure that something which I had kick-started in my tenure as the additional charge of CSIRCRI is fructifying today. I must really thank people like Madhyarasu, whom I had entrusted this task in October last year, to really have put in and ensured that this program has done extremely well today. Let me also confess that till I went into CSIRCRI as the additional charge, I was never connected with energy. I was a leather technologist trying to talk about the environmental pollution of that industry and whatnot. The only thing which I knew about energy was that my industry was in doldrums if the cost of electricity was going up. So that was the only thing which was concerning me at that point of time. But I must also say that the amount of activities that was going on at CSIRCRI at that point of time, people like Prakash made me understand too much of electrochemistry and batteries and whatnot. And I think I had also interactions with Gaudi Energy and people like that to ensure one particular aspect which CSIRCRI actually tried pushing forward. A concept which was spoken about here a little bit back, a concept which people like Dr. Mashelkar keep talking about, the one which is the the valley of death in the TRL systems. CSIRCRI had essentially wanted to ensure that the lab and the industry got connected, and one of the ways which was thought about by CSIRCRI, Dr. Sheshadri did point out this a little bit as to who should be belling the cat. CSIRCRI did try this whole concept of produce it in your own lab at the industrial scales and make the industry come forward. Of course, there are a lot of challenges associated with it, because when the lab gets into that activity, the lab stops research. They get into the other part of the site, and the next level research actually stops there. It's like the buck stops there kind of situation. But of course, in a country like India, somebody has to prove the science. And many a times, it ends up that it is the institution which has to prove it also. And that's where CSIRCRI is come in to a great extent. And I must say that the lithium battery plant which we put up here in Chennai was kind of a a new thing for the entire CSIR itself. We were not just talking about pilot plants which we had in many of our labs, but we were actually talking about real production systems. And at that point of time, I really understood, working with Gaudi Energy, with the discussions that we had, there were a lot of things which the labs never understood or the labs never bothered, which was a major concern for the industry. Starting from waste management to anything and everything, even the stoppage of work for a few minutes was a concern at the industrial level, while that was missed out in our way of looking at things. So, to put it short, I think what we all need to look together today in this institute industry interactions is how do we create an ecosystem wherein the output of the lab would be tried out at some scales by the industry, make the industry comfortable to adopt the technology and move forward. So somewhere I think there has to be a kind of bridge, and that bridge may have to be built by both the institution and the industry together. The question is, where are you going to place it? Of course, we keep saying it may have to be placed in the institute, or we may have to say that it is placed in the industry environment, etc., etc. But I always believe that this is better placed at the industrial level, because then you get to work in the industry environment. And another problem with the institutions is that though we have a lot of space, thankfully, after the proving of technology, this facility which is created becomes a kind of redundant facility, not to be used because we need then go to the next level of things where a completely new system comes in, and so on and so forth. So these are things which I think we should address today. We must really look at how do we take laboratory science. You may call it what TRL levels you want to come in. This is always a case of the chicken and the egg. There are people who say that the industry should be involved from the very beginning, conceptualization itself. There are people who say that the industry should come in only after TRL 4 or TRL 3, but you don't know where to. I myself have cases in my own institution where we have tried both the models, and I must sorrowfully say that in both the models we have either failed or we have succeeded. Both are available to me. A classical example, if I may put it, was a case where we were developing along with CSIR colleagues a system for identifying the defects in leather. We built it at the lab scale, and we thought that okay, once it is ready for demonstration to the industry, we will go to them. With lot of fanfare, we got about 50-60 industrialists come to this very campus to see the technology. But the saddest part for us was that the first word came, we do this process in 30 seconds by the human beings in the tannery. Your machine is taking 3 minutes. Defect identification of a leather done in 30 seconds by a human being in the tannery circumstances versus 3 minutes by the machine. The next thing they said, this is involving more labor because there has to be one person to take the leather out and put in and all that stuff. Fundamentally, at the end of 2 hours of discussion with them, we were practically back to the bench where we started everything. So 3 years down the lane, we were still back on this. So the question here is whether we should involve the industry right from the beginning. But what happens there is people get so bogged with the immediate requirement of the industry that the futuristic science gets stopped at that level also. So this is another thing which I think the institute industry meets should discuss. Maybe we need to have different models for different systems to ensure that we can take the science not term or medium term, but also for the long term, because that's where the country requires to progress as well. Finally, to close, one aspect which was very much discussed by Professor Shukla is the sustainability element or the greenness factor. It's now like anything that you start, even before you put the first letter on the board, the green factor has to be put in. So that we don't have to go back and bring the technology in first and then look for a pollution management system for it, or a kind of sustainability element into it and those kind of things. Obviously, the challenge is even more that we are not just looking at the environment today, The sustainability comes in all the three manners. The whole world of green chemistry is gone today. We are talking about both economic sustainability as well as the social sustainability of things. So if a battery system is going to come in and is going to replace a petrol or a diesel system, we have to even get bothered into how many people will lose their jobs if the petrol pumps have been removed from the system. So there's a social element to it as well. So these are things which we need to all be looking at even before we conceptualize things. I am very sure that meetings of this kind, which has been very, very successfully organized across the CSIR systems, will give a lot of good answers to us. I am very sure that our student population who are here, who are into the budding scientists, would understand a lot from what the industry has to say about their outlook into the new technologies and whether they are ready for adoption or why they are not ready for adoption. Thank you very much, Ramesha, for this opportunity to be here, and I'm very sure that the program that's being organized today would add up to a lot of new research to come in at CSIRCECRI, and I think we'll have our basket full for the next 10 years of research as well. Thank you very much.
Thank you, sir, for your kind words. Now, with utmost pleasure, I extend an invitation to our beloved Dr. Anandavalli, Director, CSIR-SERC, and Coordinating Director, CMC, Chennai, for our special address.
Chief guest of today's function, Dr. Venkatatri, Chief Innovation and Digital Officer, Tata Chemicals. Guests of honor, respected Professor Shukla, Indian Institute of Science and former Director, CSIR-CECRI, and Dr. Madan, Director, IGSTC, Dr. K.G. Sriram, Director, CLRA, Dr. Ramesha, Director, CSIRCRI, Dr. Alokpal, and scientists in charge of participating units of CMC, industry partners, my dear brothers and sisters of this campus, students, press and media, ladies and gentlemen, Vanakkam and Namaskar. It's my honor and privilege to be part of this energy technology meet in connection with the 1 week, 1 lab of CSIR-CECRI. Coming to, as Dr. Sriram was highlighting, the industry participation, when we have to start, as also told by Dr. Madan, there are various levels where we can, the industry can participate. One thing is like industry, also the chief guest was highlighting the industry has to sponsor or fund the research. That is one aspect which is still in a very nascent stage in concern with the Indian industries. And the trust also, like when we are co-working, we should have a trust between each of us so that the final product or final outcome is very successful. So keeping that into mind, this industry meet is very much required, like at this point of time. And the research laboratories and industries are like electrodes, and this kind of meet is like an electrolyte which facilitates the transfer of research development to implementation of technologies. And as a system, this purpose of taking lab to land is fulfilled in an impactful manner. So that is very much required. To the limited knowledge of my electrochemical chemistry, I understand this reaction will happen once this kind of meet is happening. And towards energy sector, also as we move towards global leadership, the 5 securities is required. One such security is the energy security which we require. And CSIRCRI is particularly working on this energy area. And we would also like to collaborate as CSIR-SERC. We also have the technology, like capacity building in the way of offshore platforms, or the supporting platforms, and carbon capture. And coming to sustainability, I would like to quote a Tirukural which says, Ara iyarke avani pin, pera iyarke tarum, which means that when you are having unlimited desire to exploit this world or the nature, if that is controlled, the nature itself will give all the sustainability back. So that is what I would like to say, and I would like to congratulate CSIRCRI and Dr. Ramesha for all the efforts to organize this industrial meet, and I wish There will be a fruitful discussion in all the technical sessions following up, and a lot of collaborations will also happen during this industrial meet, and wish success in their continued journey in the national development. And finally, with the Tirukkural, normally I used to quote the Tirukkural, one Tirukkural. Today with two I would like to, which is very much relevant to this industry meet. Saivanin Adi Vinenadi Kalatode Eidum Nanda Act, when it is performed, considering these factors, will be very much impactful. What are the factors? One is considering the agent whom he is to employ, and also the deed, what is desired to be done, and the time. That is very much relevant. When you do at the right time, then the tasks are very much impactful. And once again, I would like to congratulate and extend my wishes to the CSIRCRI and its family. Thank you for the opportunity, Dr. Ramesha. Thank you, everyone. Thank you, madam, for your valuable thoughts. Before concluding the inaugural session, I kindly request our director to present the souvenirs to today's dignitaries for gracing the event. Shri R. Venkatari, I request everyone for a round of applause. Professor A.K. Shukla, Shri R. Madan, Dr. K.J. Shriram, Dr. N. Anandavali. Thank you, sir. Thank you, honorable guests. धन्यवाद प्रस्ताव पर आगे बढ़ने से पहले मैं विशिष्ट अतिथियों के प्रति अपनी गहरी कृतज्ञता व्यक्त करना चाहती हूं, जिन्होंने उदारतापूर्वक अपनी विशेषज्ञता और ज्ञान हमारे साथ साझा किया, जिससे सभी को उत्कृष्टता के प्रयास करने की प्रेरणा मिली. Proceeding forward, I would like to invite Dr. Santosh Bhatt, Senior Principal Scientist, CSIR-CECRI, Chennai, to deliver vote of thanks.
Thank you. My dear delegates, industrial participants, research students who are present here, it gives me immense privilege to render a vote of thanks at this fantastic gathering. On behalf of the organizing committee, I extend my heartfelt gratitude to each one of you for gracing us with your presence at this momentous energy technology meet, organized as a part of the 1 week, 1 lab campaign at CSIR Central Electrochemical Research Institute. Your active inputs, participation and engagement have been truly instrumental in organizing this event. We express our deepest appreciation to our esteemed director, Dr. K. Ramesha, whose guidance and support have been instrumental in bringing this event to fruition. Your vision for advancing energy technology has been inspiration to all of us. A special word of thanks goes to our distinguished chief guest, Dr. R. Venkatadri, Chief Innovation and Digital Officer, Tata Chemicals, whose presence has added immense value to this gathering. Sir, your valuable insights and perspectives on the energy sector have been enlightening. We are also honored to extend our heartfelt appreciation to the guest of honor today, Professor A.K. Shukla, former Director, CSIR-CECRI, and Distinguished Professor, Indian Institute of Science, Bengaluru, and Sri Madan, Director, IGSTC, for taking the time to join us today and grace the occasion. Your expertise and accomplishments in the field of energy technology have left a lasting impact on all of us. Your talk on theme of the workshop was truly inspiring. Our gratitude knows no bounds for Dr. K.J. Shriram, Director CLRI, and also our former Director CSIRCRI, and Dr. N. Anandavalli, Director SCRC and Coordinating Director CMC, who graced the occasion and delivering the special address. Your special address sirs and madam has been nothing short of extraordinary, enlightening us about innovation in the realm of energy technology. We thank our scientist in charge, Dr. Alok Pal, for his immense help and support for organizing this event. We cannot overlook the presence of all the delegates here and attendees who traveled from far and wide to be part of this significant event. Your enthusiasm and eagerness to participate in meaningful discussions have truly enriched this gathering. A heartfelt thank you goes out to our hardworking organizing team, whose dedication and meticulous planning ensured the seamless execution of every aspect of this event. We extend our appreciation to the venue and catering staff, along with civil, horticulture, library, and all the technical team members for their impeccable service and hospitality, along with photography and videography team. We also thank our Controller of Administration, Administrative Officer, Finance and Accounts Officers, Section Officers of CSIR-CECRI and CMC for their continuous support. With this remarkable energy technology meet, we carry with us new ideas, collaborations, and renewed determination to drive positive change in the energy sector. Once again, thank you all for your distinguished presence and contribution. We eagerly look forward to all the technical sessions of the meet from the delegates. Thank you.
Few important announcements before the tea break. We request all the delegates to gather outside on the right side of the auditorium for the inauguration of the exhibition. Please feel free to grab a cup of tea while checking the exhibition. We are showcasing CSIR-CECRI's effort towards the development of green energy technologies. We will resume our activities in 20 minutes. Please assemble here at 12:20. Thank you.